All right, we're going to go ahead and get started. Hello, everyone, and welcome. Thank you for choosing to spend your valuable time with us. Today's webinar will cover Ensuring Security in Avionics with DO-178C Conformance, presented by wolfSSL Software Engineer Tesfa Meal. My name is Emma, and I will be moderating the webinar. All attendees will be in listen-only mode, and if you have questions, please use the Q&A box. After the presentation, Tesfa will answer any questions. As always, all of our webinars are recorded and made available on our YouTube channel. If you'd like to stay updated with all the latest from wolfSSL, follow us on Twitter, connect with us on LinkedIn, and subscribe to our YouTube channel. Feel free to reach out to us via email at facts@wolfssl.com if you have any further questions. Before we dive into the technical presentation, I'd like to provide a brief overview of wolfSSL. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL consists of over 50 dedicated employees, primarily engineers. And this progress is, of course, supported by a strong partner network that we are very proud of. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO-178 support, a FIPS 140-3 certification, and a FIPS Ready offering, MQTT up to the V5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfBoot, Java wrappers and JSSC support, and commercial support for curl, and our newest product offering, wolfHSM. These offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. Before we dive into today's topic, I'd like to share an exciting event we will be attending soon. wolfSSL will be at Aerospace Tech Week Americas in Atlanta, Georgia. Aerospace Tech Week Americas is happening November 19th and 20th. Be sure to visit us at booth B8 to discuss our latest innovations. Now, I would like to turn it over to Tesfa to discuss ensuring security in avionics with DO-178 support. Oh my goodness, I'm so sorry. With DO-178C Conformance.
Thank you, Emma, for the introduction. Appreciate it. Welcome to this webinar. We'll be discussing DO-178C and our cryptography security to secure communications between two endpoints for our REST. So we'll cover briefly what DO-178C is all about and which cryptographic primitives we've taken through certification evidence and our products that have gone through certification. So stay tuned. Let's see, this is already covered by Emma, but what separates us from the competition? We are lightweight, portable, and C-based. wolfSSL supports TLS 1.3, DTLS 1.3. We are, when it comes to implementing protocols, we are in the up front. We've implemented, I think we are the first in the industry to implement TLS 1.3 and as well as DTLS 1.3. We are 20 to 100 kilobyte in terms of footprint, and we occupy 1 to 36 kilobyte RAM per session for TLS, and we're 20 times smaller than OpenSSL. I'd like to mention OpenSSL because OpenSSL is a standard cryptography typically on desktop systems, but we specialize in resource constraint environment, and we have certifications FIPS 140-2, FIPS 140-3, DO-178C, MISRA, and we are dual license. So the agenda is I'll give a brief company overview and DO-178C introduction and the product certification, as well as a customer use case, complicated product that we have taken through certification. And then I'll open for summary in Q&A. So in terms of the thing that we service, we're pretty much in everything that needs security, from medical device, automotive, industrial, aviation, satellite, appliances, sensors, mobile phones, smart energy, cloud services, printers, connected homes, our emphasis here would be aviation, things that fly over population, because we have that DO-178C requirement. And we secure communication, data at rest or data in transit. We can also support firmware update using our secure boot solution to prevent malicious firmware flashing and update. In terms of the communication medium between two endpoints, it's irrelevant for us because we run at the application layer, and we establish TLS connection, whether it is TCP or UDP or Bluetooth serial, we've tested in all interfaces. The client, when it talks to a server, whether it's wolfSSL on both sides or wolfSSL and OpenSSL on the other side, or other vendors, with the transfer medium is it's kind of like irrelevant from our point of view. Okay, this has been covered. We have 2,000 OEM customers. We secure 2+ billion connections. We have technology partners, as well as open source partners. We support a number of open source projects. We constantly porting and adding wolfSSL support to them. You can actually go on our GitHub page at the OSP link and find the list of open source projects that we support. But as you can see here, we're we have partners in the silicon vendors, OS, RTOS vendors, or hardware manufacturers. So we have about 8 products, and the one that we will be covering today would be wolfCrypt in DO-178C flavor. It's the same source code that have gone through FIPS 140-2 validation, as well as FIPS 140-3 validation. Excuse me. And we have a number of language wrappers for non-C users. Our code is purely C and some assembly for optimization. But if you're a Java user or C# or Python, and you can leverage our software. We are dual license. We have commercial license as well as open source GPL v2 license. What this means is that you can actually you can go to our website or our GitHub page, download our code, evaluate, test, and if you cannot tolerate the terms of GPL v2 license, then you can obtain a commercial license from us. So we're a clean room SSL TLS and cryptography shop company, and wolfSSL owns the copyright to the source code. We do accept contributions, and all that is they have to go through a process to accept any code from outside. But the original writers of the code are still with the company. So we're a clean room. We know the code really well. So DO-178C introduction and overview. So when we talk about DO-178C, we're really talking about what is, to bring safety, and what is safety certification and certified system. Usually, safety means freedom from unaccepted risk, and certification is a demonstration of confidence in the safety of a system. And you need an approval by an individual or a company that says a software meets the safety standard. So in the United States, It's the FAA, the Federal Aviation Administration in the USA, which gives you an approval once you've got a system, whether it is a hardware or software. Uh, if you're obtaining a certification, that the FAA would go through your artifacts and determine if the system can be certified. So when we talk about certified system, like FAA would certify an airplane and engines and propellers, and there are components as part of the components are certified as part of the airplane or the engine. In our case, a software is part of the system component. And what makes it difficult with software is every line of code must be clean and traceable to requirement and test. And the challenge is, how do you verify every line of code is traceable when you've got thousands of lines of code? So DO-178C is a software consideration in the airborne system and equipment certification. It's a document put together by people in academia, the industry, and government. So it contains, it's been around for a while. It's gone through different revisions. It was DO-178A, and then B, and then C. C is the latest, and even that is, a few years old, at least minimum 10 or more. And it's published as part of the RTCA, the Radio Tele Technical Communication for Aeronautics. And so that's a document the FAA or ESA, or if you're in Canada, we had a customer there, Transport Canada, uses to approve a commercial software-based aerospace systems. You can obtain the document from RTCA for a purchase. So when you open the document, what you will find is there are objectives. So the DO-178 spec provides guidance for production of a software, and there are a number of objectives depending on DAL level. And for each objectives, there's activity to provide a means to satisfy the objective, and the description of the evidence, which will be documented as a software lifecycle data. And it notes variation in objective or independence, whether you need to satisfy independence, because the document is written in such a way that for different DAL levels, as well as certain objectives does not need to be met. So in the number of objectives are determined by DAL level, A through E. And some objectives must be satisfied with independence. Independence is, verification activities performed by a person other than the developer of the item being verified. So, another example is someone writes a requirement. You need another group within the organization or outside that reviews a requirement. So, person who created a low-level requirement-based test case should not be the same person who developed the associated source code from those requirements. So you need to satisfy independence specifically for DAL A and B levels. So there are 5 different design assurance levels with DO-178C. And software can be certified under any of the levels, depending on failure conditions. And our wolfCrypt, which is underpinning cryptography that is consumed by all our product, has been certified under level A, which is the highest. So if you look at this table shows the levels and how many objectives you need to satisfy and how many need to be independence that we described a couple, one slides ago. And for level B, there are 69 objectives, so two less than level A, and 18 need to be you would need independence to satisfy it, and so on and so forth. So by default, the software, any software, you can say, well, it's level E, you don't have no objective, and you don't need to satisfy anything with independence. So what that means is, if you've got a failure, you would have no effect on safety or workload. But in cases where level A is required, is a failure will result in death or with a loss of airplane. So any avionics systems that fly over the public space need to be certified to DO-178. And that's the reason why you need your software, including your cryptography, go through the certification and generate certification evidence for it. Because with level A, not only do you have to worry about, when you write your source code, your software, your success case, but and the failure need to be handled carefully as well. So in cases of a failure, you want to take the appropriate action. And this table shows the objectives organized by different category. So if you look at software planning process, there are 7 objectives. For the software development process, there are 7. And verification of output of software requirement process, there are 7. Go just a breakdown of the objectives if you want to have a snap, high level look at, what those objectives map to. And for the software quality assurance, there are 5. So all this should add up to 71. And this is listed in the document that I mentioned earlier. When you look at the document, it's categorized by the table titles. In terms of when we talk about traceability, you want to be able to navigate from the high-level system requirement all the way to the executable object code. And this diagram shows a bidirectional traceability between artifacts. So a traceability evidence can show direct relationships between high-level requirement, low-level requirement, low-level requirements, lines of source code that implements the requirement, and test case to verify source code correctness, and then test results. And this diagram illustrates bidirectional tracing between certification artifacts and noting the number, the objective. And this slide, I copied it from Wikipedia. It shows different coloring as well. The legend shows the traceability direction, as well as the whether you need level A or A, B, C, or for level A, B, C, D. So for instance, for this green one here, this is required for all, DAL A, DAL B, DAL C, and D. For let's see, this source code to executable object code is only required for DAL A. So that's why the color is a little bit different. So in terms of the process, how we achieve or generate certification artifacts. We work with a lab to generate certification artifacts. So we prepare the code, we trim the code. I mean, if you look at our source code right now with the default option, we've got over 250 options. So usually for a DO-178 customers, everything have to be fixed. So we go through the process of trimming the code so we can have like the right lines of count. And once we prepare it, we work with our certification lab, and they perform code review on wolfSSL product and generate problem reports. Now, once the problem report is logged, we are responsible for fixing and maintaining the code. They run requirement coverage, structural coverage analysis with modified condition decision coverage, and we develop a requirement-based test that can run to verify the correctness of the code. And ultimately, what you would get would be the certification data package. It's hyperlinked media in either ISO image or a zip file where you can unzip. So essentially, it's an HTML file. You would open, index.html file. That will open the first page of the certification data package where you will see the description of the product. And from there, you can navigate. It will list out the high-level requirement, low-level requirement, design code. So you can start from the high-level requirement. When you click on it, it would open up all the artifacts that are related to it, as well as what the high-level requirement descriptions are. And as part of that artifacts, you would get who reviewed the code and the document that was signed, and it's all traceable in a certification data package. And so you can navigate. It's linked from requirement all the way to test results. So say you start with, let's say, hashing SHA-256 or something like that. The high level requirement would say the software uses SHA-256 for message digest, and it gives you references of where those requirement came from, which is from RFC. And then you'll have a name of the person that developed the requirement. You click on it and it will bring up the design. And you click on it, you go to source code and all related artifacts with it. And for each stage, there's a review document that's attached to it. And for certification authority, SOI, or stage of involvement, we can support you along the way. So when reviewing a system or subsystems, the certification authorities like FAA would go through SOI 1, SOI 2, SOI 3, and SOI 4. Well, SOI 1, the software planning review. For SOI 2 is the software development review. Software SOI 3 software verification review. SOI 4 is a final certification software review. So when we work with the customer on a project, we determine if they need SOI relevant deliverables. Let's say, we're working with a certification lab where we're doing regular code fixes in drop. And then when we get to a certain stage, once all the software planning review, as an example, is done, we could deliver a SOI 1 delivery. And for when the development is done, it doesn't need to be 100% done. There are requirements where it's like 70 or 80. The objective, the DO-178C document describes it. And so you will have each deliverable that can be reviewed later by the certification authority as part of the bigger system. And if you're interested in looking at the details of SOI, you can look at this document here. All right, well, DO-178C wolfSSL product certification. This is where safety meets security. In top class software, safety does not imply security, not vice versa. So security software must also be safe. What does that mean? Well, for example, for DO-178C, one of the requirement is that no dynamic memory allocation and predictable execution flow. So if you've got a software that have been developed for a number of years, which includes our cryptography, our company has been around since 2004. Now you want to generate certification evidence for DO-178C to confirm with DO-178C, then if you've got dynamic memory allocation, say you got a call to malloc or free or realloc, then you will have to re-implement those to use other methods because you want to have a predictable execution flow, right? So when we talk about safe code, safe code must follow cybersecurity best guidance in the standards. Ancient mentality usually say, if it ain't broken, don't fix it. But here at wolfSSL, we're based on vulnerability management. When something breaks, be prepared to fix it, especially with security software. It's constantly evolving. We're constantly making fixes, improvements, or if there's vulnerability, fixes. Now, in terms of our offering, wolfCrypt DO-178C, which has been certified at the highest level, DAL A, and that's the cryptographic primitive used in other products, including secure boot, firmware update, and secure transport application. Now, if you look at our code base, that's humongous. I mean, we support all the known algorithms, crypto algorithms, and we've removed the ones that are unsafe. Now, we can't generate certification evidence for everything that we have. So what we do is, this is primarily driven by customers, and the list that we have here is the one that we have taken through certification evidence. We've got artifacts for it. So for hashing, there's SHA-256 and SHA-384. For HashDRBG, for RNG, HashDRBG, we use SHA-256. For HMAC, different key sizes, 256, 384. We also have CMAC, which is based on AES 256. And we've taken CHA-20 poly 1305, which gives you similar to AES GCM. When you combine CHA-20 poly 1305, you get the encryption as well as the authentication aspect of it. It's pretty fast and less code. So that's why we've taken CHA in poly 1305 through certification. We've got AES 256 in both CBC mode as well as GCM mode, and RSA key length 372 PSS padding mode, sign and verify with SHA-256. And for elliptic curve, ECC 384, the NIST curve 256R1, to do a digital signature, sign, verify, as well as share secret. You can also, the code base, the feature that allows you to import keys from outside is certified. And X509 certification, cert verify functionality has gone through certification. And in DER mode, I mean, X509 can have a DIR mode or a PEM format since we need to minimize the code, we've taken the DIR, we support DIR X509. And finally, CRL, certification revocation list functionality has gone through DO-178C certification. The CRL is primarily used with TLS, but we had specific customer that's interested in using it as part of wolfCrypt and to verify, they've got an internal network and they want to verify if the peer certificate has been is good or expired. So we've got that code base covered. And, this obviously can be expanded. And we trim the code as needed based on customer requirement. But so when we talk about wolfCrypt, wolfCrypt is really the underpinning that is used. That's the majority of the code that's used by all our product. We'll talk a little bit about our wolfBoot product that leverages this algorithms. And the same code base has been FIPS 140-2 validated. And FIPS is required by the US government NIST. If you need to sell any equipment, hardware or software to be used by the US government, you'll need to have a FIPS validated product. And we've had FIPS 140-2, certificate 3389, and there are 77 OE listed on it. And quite recently, really excited about FIPS 140-3. We were on the list for a long time, and finally we have that certificate. So what this means is that the same source code that have gone through certification, FIPS 140-2, FIPS 140-3 validated, has gone through DO-178C certification. So it's a pretty solid code. And this one is relevant for FIPS, where we can add OEs. Yeah, in terms of product, wolfBoot is currently going through DO-178C DAL A certification. It's on Tiger Lake, the 11th gen Intel core, based on Avionics system. And here I have listed the source code, which is in the certification boundary. This one, as well as this here. And then, as I mentioned earlier, wolfCrypt is the underpinning, and as part of the wolfBoot certification, we needed to take this algorithms through certification, because we need hashing, we need to do hashing, we need to do verification through via ECC, and you need all this code. And when you look at wolfCrypt code that does a functionality as like sign or verify, you're looking at, so for this particular case, the number one determining factor for cost for DO-178C is a line count. Once you get it trimmed, you're looking at like 10,000 lines of code for this, because some people would say, why is it 10,000 lines? That's a lot of lines. Well, it's cryptography. Welcome to security. Not only do you need to write a secure code, but you need to make it run fast. To be able to run it fast, you need to have a math library that does some crazy multiplication like Tumo multiplication or Karsuba multiplication, or do a transformation from one uh, one thing to another. So the code adds up. Before the wolfBoot code itself it isn't really much. It's in like 1,000-ish, 1,000 to 2,000. And wolfBoot has been written for portability and ease of use. It's written in C. It supports a whole bunch of stuff like multi-boot ELF, Linux support. It abstracts out the HAL design for CPU speed and flash. So we reduce the target specific code to the minimum. But you need the HAL code because you want to be able to unlock a flash, lock a flash, read from flash, write to flash. And it's a small footprint, easy to audit, able to run on embedded device. And we support the Gen Intel Core i7, the 11th Gen, and it can run inside UEFI environment. Then load, verify other EFI application. We support other popular architectures like ARM, Cortex-M, R, A, 64-bit, as well as 32-bit. Intel x86, RISC-V, 32-bit, PowerPC, both 32 and 64-bit. Okay, well, this is a wolfBoot features. It relies on wolfCrypt. I mean, we're using an example of wolfBoot, how it, if you want to take that through DO-178C certification, then you have to take the cryptography that goes with it through DO-178C certification, which is a majority of it. But this covers our wolfBoot product, and it supports ECC RSA for asymmetric verify, add 2519, add 448. So obviously the one that we're taking through certification is the ECC one for the cryptography, right? And it's a public key based root of trust with multiple keys. And a loader handles update between partitions. It's a power fail safe, failure roll back and version downgrade protection, and it supports external flash memory if you don't have enough flash in your system. And it supports bootloader self-update, but this one is not power fail safe. And we also support encrypted updates and delta updates as well for if you want to save time uploading your changes. In terms of the key management, you would generate a key pair once on your server, and the private key is always on a server, never shared. The public key is stored on a target for bootloader access, and there's no revocation for public key except for bootloader update. And the security relies on unique private key for cloud and based in update signing. And the signing tool attaches a manifest header to the image. The signing tool comes as part of the product with wolfBoot. And the manifest used to validate image integrity and authentication. And the firmware version is also part of the verified payload and cannot be altered without the key. And wolfBoot relies on trust anchor to embed the public key used to verify the signature. I mean, you keep the private key, but the public key need to be on the target, and you need to anchor that to protect it. In terms of boot strategy, there are two. There's AB update or boot update strategy. For the AB update, you need two partitions in non-volatile memory, shares the same hierarchy level. New update goes to the unused partition. Old firmware is kept for fallback. And for the boot and update, active firmware always boots from one partition, update stored in a second partition. content of the partition is swapped during installation, second swap during fallback, and during the update, there is a state that we keep track of. So in case of a power failure, we can rewind and restart from a place where an error has occurred. Okay, so that covers wolfBoot product. Here we've got wolfTPM is currently going through DO-178C certification as well. And files currently in the certification boundaries are listed here. This is to be used for TPM 2.0 usage, because usually if you want to have like, trust anchor, and you can use wolfTPM as a place where you can store your keys. So secure boot can help prevent your avionics system from becoming $1 million brick. Okay, so this one is wolfTPM, TPM 2.0 library. What it is, it's just a lightweight TPM 2.0 library. It's written native C code, single IO callback, no external dependency, compact code size, minimum memory use. And we, in terms of the transport interface, uses SPI and I2C communication. And we've got examples for, Raspberry Pi, STM32, Atmel, and it's tested on ST33, Infineon. You can, since we were dual license, you can actually go look at the example code for either, wolfTPM or wolfBoot or wolfSSL or cryptography on our webpage or on our GitHub page. In this particular use case, a customer use case for certifying wolfBoot is on the 11th gen Intel Core processor. It's a sophisticated one. There's an FSP that comes from Intel, which is responsible for initializing memory controller in preparing memory sections and in charge of silicon initialization and complete and easy customization of the silicon. And then you've got the Intel Boot Guard, which provides root of trust for verification and measurement of the boot process. Requires a few Intel specific ingredients there. And you need a PCI and peripheral initialization, which requires bootloader support for dynamic device enumeration. And so this slide shows, how wolfBoot can be used as, stage 1 or stage 2, and the interaction between, when you have the green one is a reset. The green one is Intel Boot Guard. You've got reset vector, wolfBoot stage 1, FSP temp, FSP man, and you use your key to generate, to sign it, and you pass control. The Intel Boot Guard verifies everything. If everything goes well, then the stage 1 now, which is wolfBoot, verifies your OS kernel or whatever software you need to load using another key. So the stage 1 loads execute Intel FSP, memory is initialized by FSP, verify authenticity of the last FSP, and then verifies wolfBoot stage 2 code, and then wolfBoot stage 2 will take over, and it can select image to boot and verify the authenticity of the image, and then loads in stage OS, right? So as part of wolfBoot stage 2, you've got wolfCrypt that is used to verify an image. You've got the public key, which is stored as part of the wolfBoot stage 2 image, and that public key will be used to verify the intensity of the image. And currently it's the ECC, the elliptic curve that we've customer using to and we've decided to take that through the certification evidence. But this is like a complicated case. But in terms of, if you need only an encryption algorithm, we've got customers that only need encryption algorithm, say like AES, GCM, key size 256, or if you can have like just hashing only algorithm, which is only like 200 or 300 lines of code. But when you have public asymmetric cryptography for signing and verifying, takes a lot of code to implement that. And the benefit of wolfBoot is performance, because you can leverage acceleration on the target with using Intel AVX2 or Intel ASNI. And obviously the one that we described is DO-178C certification, certified secure boot solution, and ability to integrate special features into boot sequence. So if you want to do custom, so we've replaced the Intel Slim bootloader. And let's say, in the use case that I described, use wolfBoot as a second stage bootloader to Intel boot guard. The TPM was used to seal and unseal password, to unlock SATA drive and boot an OS image. So the TPM is used as a trust anchor before you can unlock a SATA drive, and that's where you get your password. And it's time-based verification as well. And we've made a number of modifications so that wolfBoot can be a replacement for Intel Slim bootloader. The modification is to allow Intel FSP microcode API support, stage 1 memory initialization loader, the drivers, multiple sign partition support, multi-boot and ELF2 support, and to integrate power on built-in tests, and to get that sealing and unsealing of a password to a TPM-based root of trust in major boot, and SATA drive unlocking. So I know we discussed wolfBoot in this webinar, while the focus of the webinar is DO-178C as well as cryptography, but this demonstrates that wolfSSL team can easily make changes to meet your requirement, any really avionic, to meet your avionic needs, including, let's say if you need wolfSSH or wolfMQTT, which is on the roadmap, but we need a customer to come forward before we can generate certification evidence for it. And wolfCrypt plus wolfBoot is the only DO-178C certified secure bootloader solution available today. If I am wrong, we'd like to know who has it. So why replace your existing bootloader with wolfBoot? I think I covered this. DO-178C certified crypto. It's the same cryptography that has gone through FIPS 140-2, FIPS 140-3, CAVP and ACVP validated cryptography, hardware-based cryptography, or platform-specific assembly to accelerate some of the computation. And if you want to interface for a secure key storage like TPM 2.0 solution, or if you need customizable boot process integration. So what does wolfSSL DO-178C product means for you? So if you have a need for general cryptography, message digest, sign, verify, encrypt, decrypt, or secure boot, or secure firmware update, or secure key storage via TPM 2.0, so we can easily meet your needs. And I think Emma mentioned that in the beginning, we do provide 24/7 support. So wolfSSL team is actively maintaining support this products. You can get different support packages. And if you want to keep cost at a minimum, wolfSSL team works with each DO-178C customer to trim a code down to the minimum requirement, and code trimming reduces line count to a minimum for lowest cost certification. I think that was it. Well, I believe we've covered DO-178C certification, why you care about DO-178C certification. We covered cryptography. We cover customer use case of wolfBoot on Intel Tiger Lake, and as well as the other details. So I think we are good now. I can open for questions.
Fabulous. We already have a few that have come in. What is the difference obligation of using either the commercial license versus the GPL?
So the GPL, you can download, evaluate, and test using the GPL code. But in terms of functionality, they are identical except for the licensing. But if you've got a product that you want to commercialize, you can't really use the open source version, because you need to open source your design as well. So if you've got a commercial product, then you need to obtain a commercial license, and you can obtain that from us. But in terms of functionality, it's identical code.
Fabulous. For which CPU architectures has wolfCrypt achieved DO-178C certification?
Oh, that's a good question. So when you do DO-178C certification, not only do you have to worry about the source code, but you need to know, the hardware as well as the compiler. So for the hardware architectures that we've taken through certification, we've got different ones. We've got PowerPC, ARM, Intel, both 32-bit and 64-bit. So I think that covers it. We haven't done RISC-V yet, but if we have a customer that move forward, it would be nice to get that. But yeah, I hope that answers your question.
Yes, I think it does. And then final question here, where can I find your DO-178 source code or certification data packages, and are they available for public viewing?
So yeah, I understand that we covered our code base is available online, but for the DO-178C, it is not. If you do want to get a sample, or if you want to set up a meeting to go in details of what the certification data package contains, you can always reach our support. I think support at wolfSSL.com or facts at wolfSSL.com. But that source code is not available for public viewing.
Wonderful. Well, thank you, Tesfa, for hosting an informative webinar. Thanks to everyone for joining. I will email a copy of the webinar recording and PDF slides. You can keep up with our upcoming events, meet our team in person, read our blog posts, and get the latest wolfSSL updates by following us on X, connecting with us on LinkedIn, and subscribing to our YouTube channel. If you have any questions at all, don't hesitate to shoot us an email at facts@wolfSSL.com. We're here to help. Thanks again, and we look forward to seeing you next week on November 12th for post-quantum cryptography update tailored for the Asia Pacific time zone. Thank you all so much.